Okay, 1999 Chevy Suburban with a no start. We've already confirmed we have spark. So our next step was to connect the fuel pressure gauge and to look at fuel pressure. Let me zoom on the gauge and, all right, go ahead and crank it. Crank it again. All right, good. So as you can see, we have no fuel pressure. And what we want to do is do some basic tests with this one. We're not using a scan tool. We're just going to use a multimeter and a test light, and we're going to confirm what is causing our no fuel pressure problem. Okay, so our next step is we are at the power distribution box under the hood, and we've already identified our fuel pump relay, which is right here. It was nice of GM to provide on the cap itself location of the pump relay. And what we're going to do is we're going to pull this relay out and do some voltage checks next. All right, so we're going to do some voltage checks. We're going to use the test light first at the power distribution box. A little bit background on these pins on this relay. Pin 30 and 87, that's top left and bottom right, would be my load side switch contacts, normally open. Pin 85, pin 86, bottom left and top right would be my control side of this relay. Now you got to remember when you're looking at these that it's going to be backwards when you plug it back in. So it's opposite of the way you're looking at it here when you plug it back into the car. But what we want to do, as with any relay, is we want to make sure that we have two power feeds. There should be two power feeds on most systems, at least fuel pump circuits for sure. Two power feeds, one control side power and one load side power, and we're going to check for that first. So go ahead and check all four of those outer pins. We're not worried about the middle one, 85. Got a little shadow there. Well, let me back up just a little bit. Okay. Is our key on right now? So bottom left, we got power. Okay, and that bottom left would be looking at this relay. Bottom left would be, again, flip this over. It's going to be pin 87 is bottom left. Okay, so we got power on pin 87. That's going to be my load side power feed. Check the other three. Got nothing there. Got nothing there. And nothing there. So we're missing a power feed. Well, GM fuel pumps, the computer controls the power. So we need to crank it to see the other power feed. Can you crank that, Kenny, and check those three again? All right, let off the crank. Stay right on that pin. That's going to be my control side power. Turn the key off and wait for a second, then turn the key back on. We should see a prime. There's your 2-second prime, so the computer's definitely in control of this relay. So that's the two power feeds that we need for this to function. So pin 85, pin 86, it's a power side switch circuit, and you are on what, the bottom right? Bottom right is going to be pin 85. So pin 86, which would be the top left for you, should be a constant ground if we are correct in what we're doing. And so what we want to do is switch our test light polarity, and you can use the power distribution box to do that. Right there on the side, we're right on that stud. Check your light, make sure it lights. Okay. Pin 86, top left, constant lit. So we have a constant ground on pin 86. We've definitely checked this relay correct. Pin 85 is powered by the computer. Pin 86 is a constant ground. So what we need to make sure at this point is that this relay is actually functioning and switching. Problem is, it's in a power distribution box and it's not easily done. So we're gonna do some checks back at the tank for that, but that's how you do your checks up front. I want to show one other characteristic while we're here on this design, and that would be if you were using a voltmeter. Go ahead and connect the test light back to battery ground. And we're going to focus on that computer control pin 85, that bottom right corner. And I want you to put your test light back on that again. And you're going to notice that right now with just the key on that our test light is not lit. Okay, take your test light off, turn your voltmeter on. Good. And I want a voltage reading with the voltmeter. And the odd thing about this is we have 12 volts on this computer control wire. That 12 volts looks like right now that we're turning the fuel pump on and running the relay. That shouldn't be there. We never run fuel pumps all the time with just the key on, so why are we reading 12 volts on this circuit? Here's what I want you to do now. With your test light, no, keep your voltmeter there. There you go. And touch your test light, which is connected to ground, on the tip of your voltmeter. Notice it pulls it all the way down to 0, and my test light is not lighting. So this is confusing, but power side switch circuits on some cars will run a bias voltage to the component from the computer that is normally not seen if the component is plugged in. You can only see it if the component is unplugged or if there's an open in that coil. That is what you're looking at on this circuit. I actually have this in my book, section 3, page 26. I have a description of this scenario where there's a bias voltage that is being used inside the computer. I'm going to show you that real quick. Okay, real quick, what I want to do is explain this power side switch circuit and this bias voltage that's used on some of these. And this is section 3 in my book, page 26. You guys can refer to this. And there's a description on this, and this was on a specific vehicle. It was on an air ride suspension solenoid on a Ford, and I had done this exact scenario. I think to make this a little bit easier to understand, I've kind of redrawn it just as a basic circuit, fuel pump relay. And this is the PCM right here. It is a power side switched relay, externally grounded on the control, internally sourced. The computer's providing power to this relay with a transistor. So just to talk about what we saw, our initial tests, with the relay removed, we were actually seeing 12 volts on this circuit. We had two actually. We were reading 12 volts on this one, and we were reading 12 volts on this one. Load side power and control side power. And so it looked like the relay was on, but it wasn't. And the reason we knew it wasn't is when you plug the relay in, it never clicked, and the pump was not running. So what was this? What were we looking at? On a lot of power side switch circuits, the computer's actually using a bias voltage to monitor the circuit. And so I'm showing that as a resistor inside of here. Now, I'm not an engineer. I don't make these circuits. I don't know exactly how it's done internally, but I'm telling you that it works like this. And so you have a very high ohm resistor here. Maybe it's 100,000 ohms. Maybe it's more than that. I'm not completely sure. Again, I don't make the circuits. But what is this resistor doing? How is it affected? If this driver is off, there is no power making it through this transistor on its way to the relay. So the voltage that you're seeing here is actually coming from this resistor. It's going to run through the resistor. It can't go that way, and it comes out here. The reason it's at 12 volts is there's nowhere for this voltage to drop. Even though there's a resistor, there's no current flow here, so there's no voltage drop. When the relay is plugged back in, the reason this same circuit at 12 is going to be 0, and this one's 12, this one's 0 with this transistor off, is now this resistor inside the computer actually has a ground, and that ground is through the relay coil. it pulls the voltage all the way to ground. Now there would be a few millivolts on there, but we weren't on that kind of scale. It was basically 0 volts with that relay plugged in. So again, unplug the relay, and you lose this ground for this internal resistor. And that's what it would look like. And it can be confusing because it looks like the circuit's on and it's not on. It's a bias voltage. You just have to know it's there because it can really mess you up on a diagnostic process. So bias voltage, power side switch circuit, look for it. It's there on a lot of cars. And this actually, for diagnostic purposes, let's say that we were worried about, this circuit not functioning. We were worried about the computer wire. We were worried about opens or shorts. Simple unplug it test. That wire going to 12 volts would tell you the integrity of that control wire is good. So inside the computer, the way this would work, this would be used for trouble code diagnosis. This computer is responsible for turning this transistor on. So that circuit that's going to do that, this little microchip or whatever they're using to control this transistor, is also going to be monitoring this leg of the circuit. What this computer wants to see with this circuit off, it wants to see 0 volts here. With the transistor off, it should be 0 volts. If that transistor is off and it sees 12 volts on this leg of the circuit, you get an immediate trouble code. Without it even turning that circuit on, you're going to get a trouble code on this design. That's why it's there. It's for diagnostic purpose, and it can definitely throw you off. You saw it on the truck. That's what we had. And if you notice too, when we put the test light on this, circuit, this voltage dropped all the way down to 0, and the test light did not light. Why? Because it's got a really high ohm resistor that it has to travel through, and that's not going to be enough to light that test light. The test light actually acts as the coil and pulls it all to ground. Bias voltage, power side switch circuit. I have a description of that, again, in my book, section 3, page 26. You guys can review that, plug that information into what we just saw. Alright, so the key is still on, and this is our wire right here, this pin 86, this computer controlled wire. You see it's reading 12.4 volts, 12.45, and what I want to show you is I'm going to plug the relay in, and I'm just going to use a T-pin and put it in there so I can access this pin with it plugged in, and I want to show you that 12 volts with this relay plugged in is going to disappear. Got no volts on that wire. That's the same pin that I had 12 volts with the relay unplugged. Josh, can you do me a favor? Yeah. I'm going to leave my T-pin here. Can you reach down and unplug the relay? Watch the voltmeter. Plug the relay back in. And you see it drops to 0. Unplug the relay one more time. It jumps up to 12. That is not being switched on right now. And if you were just using a voltmeter on this, it could be confusing. A little bit on power side switch circuits though. Some power side switch circuits use a bias voltage for diagnostic purposes. That's what's going on here. And that is why this test light, when we put this test light on this pin, actually the test light would be less misleading than the voltmeter if you didn't know about that. Notice the test light is not lighting until I reach in and crank this vehicle, and now it lights. Okay? Take the relay one more time. Kenny, I'm going to need you to crank it for me this time. So relay unplugged. Key is on. Relay unplugged. There's my 12 volts. Got to plug the relay back in. Can you plug it in all the way? Not with my T-pin. Let me move this. Hold on. Unplug it. Let me get this in a different spot. I can't hold it. Okay, go ahead. Wait a minute. Okay, good. Crank it. Okay, good. So that's the voltage that's turning it on. You see it dropping to 0, crank it again. Okay, unplug the relay. Relay out of the picture, got 12 volts there, crank it. It goes from 12 volts, right? Crank it. And of course, system voltage is gonna drop when you crank it. So, looks like the circuit's on all the time. It's not. That's not the purpose of this scenario that we're going over right here. Has nothing to do with the pump and not operating. I just wanted to show that characteristic. We're gonna do an amperage check next. All right, so our relay's functional, our computer's functional, our load side feed is good, our control side feed is good, our control side ground is good. To check the switching of the relay, we can do that up here, but I'm gonna prefer doing it back at the tank because even if it does show us good switching side, load side feed to the pump, if that shows good, we still gotta go back to the tank anyway. So we're gonna jump past this part, go back to the tank. Now, the thing about doing fuel pumps is fuel pumps aren't running with just the key on. You need to crank the engine over. And by the time we identify a good ground underneath and identify where our power wire is, we're gonna, overheat the starter and kill the battery. So what we're gonna do is jump the pump from the front. We're gonna jump this relay. I wanna warn you guys though, if you do this wrong and you jump the wrong pins, you have the potential of frying the engine computer. If we accidentally jump pins 85 and 86, when we think we're jumping 87 and 30, we're gonna have a major problem if our key is on or if you attempted to crank the engine and that driver happened to turn on. So, real important that we do this right, and again, this is where we get our numbers backwards, we're gonna have a problem. So we wanna go 87 and 30, and that's gonna be the bottom right and top left, but you gotta remember, when you flip this over, it's gonna be backwards. So it's gonna be top right and bottom left instead of bottom right and top left, okay? So it's really important we do that correctly. So let's get our T-pins and our jumper wire installed. And when we put these T-pins in, we are not putting the T-pins in the female terminals themselves. We are putting the T-pins next to the terminals because we do not want to spread the female pins apart and then the relay is not going to fit properly. Get you some light on this subject there. You sure you're on the load side? Josh?
What?
We positive we're on the load side? Double check your relay. Make sure you're in 30 and 87 and not 85 and 86. If you're in 85 and 86, we're gonna cook this engine computer. All right.
We're good.
So we're gonna run just a jumper wire across that. We're not worried about the current measurement. We can use the ammeter too if we want, but it's only a 10 amp scale and some of these Vortec pumps will draw about 10 amps and we don't wanna blow your meter. So we are using a fused jumper wire in case we're up in the air and something touches ground so we don't have a fire. Don't let those alligator clips touch each other.
It's gonna shock me.
It's okay. No, it's not going to shock you. Just a little bit of arcing is just the pump turning on. So there is current flow. That's fine. We can put that piece of paper in there. All right, good. So our circuit is activated. We are loaded. We don't have to crank the engine over. Our pump is running all the time right now. We're going to put the truck up in the air and see if we have a good power and ground. Again, with the pump circuit energized and loaded, we still have no fuel pressure. Actually, maybe a couple pounds here. Can you hold that right there for me? Get a shot of that gauge in the picture. So even with the circuit completely energized, we have no pump pressure. So we're going back to the tank now. All right, so we're up in the air. This pump is running, we can hear it. We did a current measurement up front. We had 2 amps of current. These things draw about 8 to 10 amps normally on these systems. And what we noticed, somebody was just here. We don't know history on this car yet. We're gonna have to call the guy. But these pump strap bolts were just taken out. We see nice shiny metal on here. Somebody was just here, and we have further evidence of that. We come up here to the pump wiring. Now we pulled this out of the harness. You can't get to the connector on this one, but right where the harness goes into the back, the tank area, there's a differential, and that harness right here, the plug's up there, so we can't get to that, but we can get to the wiring, and you can see that someone was here already. There is some definite marks in the wiring that somebody was here, and it almost seems like maybe somebody just put a pump in this car, and if that's the case, what they probably did was not put it together properly, and it's actually running and spraying inside the tank instead of up into the pressure line. But we're gonna do our checks right here. We're gonna go after the gray wire, which is the pump feed. Now there are 2 gray wires. I'm not sure why offhand, but we'll check them both, and then we'll check our 2 blacks. So not worried about the green, not worried about the purple. We're worried about gray and black. Okay, one of the hard things to do when you're under a truck, especially here in Pennsylvania in the Rust Belt, is finding a good ground. And what I've found is brake lines and fuel lines usually make pretty good grounds for a voltmeter. So we're gonna try that first. We know the pump's running, and we're gonna base our voltage test, our result here, on this feed wire as to whether or not this ground is good.
This gray has no voltage.
One of the grays has no voltage?
Yep.
All right, go to the other gray wire. And somebody's already poked holes in these wires for us, so kind of makes it nice.
This one's at battery voltage.
Yeah, can you move your middle finger? Yeah, there you go, so I can see which one you're on. So we're just touching on the gray wire, and let me get a look at your voltmeter. Okay, that's our feed to our fuel pump, 12.4 volts, so we know our wiring is good from the front of the car at the power distribution box all the way back. And we still have no fuel pressure, so pump is running. I can hear it. We're going to do one more check just because, and that's the ground. Make sure we got a good ground. All right, we're going to check our pump ground now. There are 2 black wires, and I'm not sure which one the pump ground is. We just want to make sure both of these wires stay low voltage. We didn't move our multimeter lead. Negative is still on the frame or on the brake line, which was a good ground. And you know, you're going to see in some circumstances, depending on the amperage of a pump, you're going to see a few hundred millivolts on a pump ground. This one being a very low amperage pump right now, I don't think we're going to see much at all. We just want to make sure we don't have any high voltage on these. That one's at 0. Go to the other one. And we'll make sure that they're both low. They are both low. So we have good pump ground. We have good pump power. We got low amperage to this pump. So we got to drop the tank now, see what's going on. If somebody just replaced this pump, then they didn't put it back together right, and that fuel's just spraying unrestricted everywhere inside the tank. All right, so we were right. Somebody was here, just called the owner, and they just put a fuel pump in it. And before we dropped it any further, we have the fuel tank pressure sensor unplugged to give us room, and this is one of the newer style plugs that you have to rewire. And what we are seeing is this thing was wired backwards. They have the gray wire, this is the harness side that I'm holding, going to the black wire on the pump, and then they have the black wire on the harness going to the gray wire on the pump. So this pump is running backwards. We're gonna fix this wiring the way it should be and see what kind of pressure reading we get. They went from the purple wire, which is the sending unit, this is harness side, to the sending unit ground, and then they went on the sending unit ground harness side to the sending unit signal. So even the sending unit's backwards. So we need to switch those around too. Now, one other thing that you guys need to know when you're dealing with these is there's 2 black wires. Do not mix these up. One is a heavier gauge that's lower on my finger, is a heavier gauge black wire. That's for the pump. The smaller gauge black wire is for the sending unit. If you mix these 2 grounds up, you're gonna pump 10 amps of current into the computer ground circuit and wig every sensor out on this car. So don't do that. We don't wanna mess that up either. We're gonna reverse the wiring on this and see what kind of readings we get. Keep in mind we had 2 amps of current flow. I know I didn't show that. We did a measurement. 2 amps of current on this circuit and no fuel pressure. Let's see what we got when we're done. All right, so we have our wiring fixed on this. We'll put a pressure gauge back on it in a minute. See if we get pressure on this. Go ahead and start it. You cc runs. So we definitely had some reverse wiring on this pump. We'll do two things. We'll get a pressure reading and we'll get an amperage reading at the fuse box to finish up this video, but that was it. Reverse wires at the fuel pump. Okay, just so a review here, safety, make sure you're in the correct 2 pins when you do this. And what we're gonna do is we're gonna jump the pump, bypassing the relay. This is after our fix. We heard yesterday, of course, the truck runs, so go ahead and jump that. Let's see what kind of pressure we got. Of course. And that was an immediate build of pressure to about 62 pounds of pressure, which is pretty typical for a Vortex system. That's great. Gotta take that off. And of course, pressure should hold. Looks like we have a little bit of a bleed down issue here, but that's not really the purpose of this video. So that's a fix. Reversed wiring to the fuel pump. We're gonna do one last check and we're gonna get an amperage measurement up front. And this is helpful to be able to do up here instead of crawling underneath, especially if you're working on the ground or you're in a gravel driveway and you don't feel like crawling underneath, checking pump powers and grounds. You can do an amperage measurement, so we're gonna do that to just get an idea what this pump draws. We had 2 amps before. I wish I would have shown that. We didn't. We had 2 amps before. Let's see what we got now. All right, so we're using our ammeter now. It's connected. It's going to be connected in series. Remember, you want to think of your ammeter as a jumper wire with a gauge on it. So we're going to do the same thing we did with the jumper wire using our multimeter leads. Go ahead and hold it there. And we're running about 7.5, roughly 7.5 amps of current. And these will run higher amperage because they're higher pressure. So we had 2 amps before, we now have 7 amps. And of course we could put a scope on this and do all kind of calculations, but that's really not important for what we're doing. The scenario here would be very useful if you were to do a job like this and you had low fuel pressure and you were worried about it being a power or ground problem. If you came up front and did this check and you had 7 amps, 8 amps of current, there would be no reason to crawl back under the vehicle to check your power and ground. They're good. You could do a pump, you could put a pump in it just for that test. So a very valuable test to do, and that looks great. We're done.